Functions are f of alpha and g of beta. Now we have to check f of alpha into g of beta whole inverse is how much. Now f of alpha into g of alpha, g of beta will be nothing but cos alpha, cos beta minus alpha, sin alpha to cos alpha sin beta and sin alpha cos beta, then cos alpha, then sin alpha sin beta minus sin beta 0 cos beta, whereas the determinant of f of alpha into g of beta will be 1, and it satisfies the property. That means f inverse f of alpha into g of beta whole inverse will be equals to g of beta whole inverse into f of alpha whole inverse. By finding g of beta inverse and f of beta inverse, and if you multiply you will get this inverse. So the answer is option D. They have given the assertion as box P comma Q plus R comma S minus T. We know that box ABC is nothing but A dot B cross C, that is P dot Q plus R cross S minus T. And if you simplify by using the vector vector definitions, you will get the answer as PQS minus PQT plus PRS minus PRT. That means the given assertion is true. And also we know that scalar triple product is commutative. Yes, scalar triple product is commutative. So assertion is true and reason is true, but reason is not the correct explanation of assertion, because we are not using only commutative property here. So the answer is B. 4 points, and also they said that they are coplanar and we have to find the value of lambda. Now, whenever they will give you 4 points, convert them into 3 lines. Let the given points be A, that is minus 6i plus 3j plus 2k, B as 3i minus 2j plus 4k, take C as 5i plus 7j plus 3k, and D as minus 13i plus 17j plus lambda k. Now from this, convert them into 3 vectors. So take the vectors as AB, AC and AD. Now AB is nothing but OB minus OA. So AB will be nothing but 9i minus 5j plus 2k. Similarly, AC is 11i plus 4j plus k. And AD will be nothing but minus 7i plus 14j plus lambda minus 2 times of k. Now, as the given vectors are coplanar, then the determinant must be equals to 0. So, box of AB, AC, AD will be 0. That is 9 minus 5, 2, 11, 4, 1, minus 7, 14, and lambda minus 2 must be equals to 0. If we simplify, we'll get it as lambda plus 1 is equal to 0. That is, lambda is equals to minus 1, option C. Integral 0 to pi by 2 cos cube theta into sin cube theta d theta. We have to find the value of this integral. Now this integral can be written as beta of m by n. Now look into these exponents. Exponents are nothing but odd numbers. So we can write them as 2m minus 1 and 2n minus 1. So this expression, this integral can be written as 0 to pi by 2 cos of 2 power m minus 1 theta sin of 2 power n minus 1 theta d theta, where 2m minus 1 is nothing but 3 and 2n minus 1 is nothing but 3. So beta of the values of m and n are 2 and 2. So the formula is rho of 2 into rho of 2 by rho of 4, which is nothing but 1 into 1 by 3 factorial, which gives us 1 by 6. That is nothing but option B.
Of d square z by dz square plus z is equal to 0. Okay, he has given, I can write this one as d square by dz square into z plus z is equal to d square plus 1 into z is equal to 0. Okay, he has given two conditions here. When x is equal to 0, z is equal to e power 2y. Similarly, when x is equal to 0, dz by dx, which is equal to 4. Okay, now what is the solution for d square plus 1 is equal to 0? Okay, the solution is a cos x plus b times of sin x. Okay, this is the solution for d square plus a square is equal to 0. Now here z is a function of x and y. So I can write this one as z is equal to f of y sin x plus g of y cos x. When x is equal to 0, what is that? Z is equal to e power 2y. Substitute here. Okay, z is equal to e power 2y. So e power 2y is equal to f of y into sin x. Sin 0 is 0 plus g of y cos 0 is 1. So I can write from this g of y is equal to e power 2y. Okay, or one more condition is dz by dx is equal to 4. Okay, dz by dx is equal to 4. So this is equal to f of y into cos x minus g of y into sin x. Okay, now when x is equal to 0, this condition is equal to f of y. Okay, so what is the solution here? Z is equal to f of y, so 4 times of sin x plus g of y e power 2y times of cos x. So option C is the correct answer. Option C is the right answer. The circuit shown below, the value of current I is. Okay, we can solve by using Milliman's theorem, or we can solve by using nodal analysis. Okay, second one is preferable because it will take less time and no need to remember any formula. Okay, now let us take this as 0 volts node and this one as potential at V. Since this all are connected in parallel, now what will be the nodal analysis here? Let us take these two terminals and A and B terminals and open circuit these circuit across load terminals. Okay, now what is the nodal analysis when load terminals are open? V minus 4 by 2 plus V minus 2 by 8 plus V. Okay, V minus 4 by 2 plus V. This polarity is different here, minus and plus, so this should be V plus 8 by 2. Okay, V minus 4 by 2 plus V plus 8 by 2 plus V minus 12 by 2. Similarly, V minus 16 by 2 plus V plus 10, since polarity is again different, which is equal to second one, by 2 is equal to 0. So this is V into 5 by 2 is equal to V into 5 by 2, since we have 1 by 2, 1 by 2, 1 by 2 5 times, is equal to 4 by 2 is 2 minus 4 plus 6 plus 8 minus 5. Okay, so this is equal to 2 minus 4 minus 2 plus 6 plus 4 plus 4 plus 8 is plus 13 minus 9. This is around 7 volts. Okay, so V is equal to 14 by 5 volts. Okay, now what is current I here? From this, if you see this one, current I is equal to voltage at this node by resistance. So I is equal to V by 4. So this is 14 by 5 into 4. So this is 14 by 20, which is equal to 0.7 amperes. Option C is the correct answer.